Now, interference. There's a bit of a focus on this in safety, and we're on the tail end here. That picture on the right-hand side is actually in my shack with me transmitting on 6 metres, so 50 megs, and that's the ABC television signal. Because my television antenna is actually right next to my transmitting antenna in that particular case. So that is RF getting into the television. I transmitted and I went, ooh, I'm going to take a photo of that because I can use that to teach. Okay, now interference, a broad sweeping generalisation here, can generally be resolved with technical solutions. However, these can be as complex as you want to make them. Most equipment that you buy has a rating, an electromagnetic compatibility rating. So the equipment has been tested to be immune from RF, for a certain level of RF, and so it has what we call the C tick, which is the little tick. It's not the China tick, it's the C tick. Unfortunately, I think China's realised that if they put that on all their equipment, we think it's certified, which it's not, because it's usually got a number next to it. So most equipment has been tested to be compatible or immune to RF fields of a certain level. Reiteration, we cannot cause harmful interference, so that's, I think you drum that into you. And electromagnetic compatibility issues are likely to cause neighbourhood disputes. So one of the ways that the ACMA would like radio amateurs to try and resolve these disputes, and if you have a dispute and you go straight to the ACMA, they will ask you a whole lot of questions about what you did to try and resolve it yourself. And if you haven't done those steps, they're probably going to ask you to go away and do those steps. So discuss it with the neighbour or whoever. Take a log of the dates and times, hello Greg, of the interference, because you may not have been transmitting at the time that they were experiencing interference. So it may quite possibly be something else. Try and identify the source of interference if you can, and seek advice, and where necessary, once you've done all those steps, the ACMA has a wonderful little pamphlet on interference and the steps you go through. That's available on their website. And they will ask you whether you have done those steps. It may be necessary to shut down your station for a time. This is not mandatory unless the radio inspector tells you that. And unless the interference is deemed harmful. And it might be because the neighbours have crappy electronics or whatever. So there needs to be some diplomacy and some negotiation. Many sources of potential interference. Power tools are great. Arc welders are wonderful spark transmitters. They transmit on all bands all at once and at reasonably high power, because that's how they work. It can be caused, interference can be caused to a whole range of things, many things. The very last one there, the blasting devices. If you've ever been past a mine, there is usually a sign on the mine that says no transmitters. That's because a lot of their fuses are electronic fuses these days, so they really don't want you transmitting and setting them off and all sorts of things. So that's the reason for that. Many sources of natural interference as well. Lightning. Once you start listening on HF, when you get your license and you're listening on HF, you will know when there is a storm somewhere in the Asian region. Because you'll hear lightning crashes. And they'll get closer and closer, and you'll probably think, I better probably undo my antenna. But you'll hear that sort of noise, the natural noise of lightning, electrostatic build-up, etc. Now, there is also, if you're incorrectly operating your station or turning that mic gain up to 11 and trying to get a bit more out of your station, etc., there is a possibility that you'll cause interference. And so you need to know how to correctly operate your equipment. Overmodulation, excessive mic gain, not matching your antenna. With 10 watts, you're probably not going to cause that much interference, but as you increase your, you go to standard and advanced, you've got the potential for a lot more interference to be created. Breakthrough on FM and SSB. Now, breakthrough, that picture of the television with the interference, that's breakthrough. It's actually strong enough for it to start pixelating a digital television, which is pretty significant. Because there's a whole lot of error correction in television signals. Mains fed interference. Now, the signal comes in through your mains cable. This is one of the hardest ones to track down. So yeah, but it can come in through the mains cable. Resulting from interference resulting from EMC issues depends on. Now, there's normally a question in the exam around this. Depends on the transmitted power level, the frequency of operation, the type of emission, so the type of mode that you're using, and also the distance of the transmitter to the antenna. So in a lot of cases, if you're having trouble with your neighbour and they're interfering with their television, and you happen to have your antenna, 2 or 3 metres away from their television antenna, it's probably a good idea to try and move your antenna to the other side of the house and get some distance. And honestly, in a lot of cases, that fixes the issue. Distance. That inverse square law. You don't have to move it very far for it to actually drop in power level. Filters. You put filters in. In fact, as part of the practical, I'm not quite sure why we get you to do this, but it is part of the practical. You can use, these are toroid cores available from Jaycar, and we get you to actually wind a toroid core. Who remembers when you had your GSM phone, and when your GSM phone was about to ring, you could hear it in your computer speakers? Now I'm dating myself there, but anyway. If you got your speaker cable and you wound it through one of these toroid cores, it would magically disappear. And so the RF energy, which is being picked up by the antenna, basically your speaker cable, is absorbed in the RF material of the ferrite and dissipated as heat. But we get you as part of the practical to do that. I'm not quite sure why we do that, but anyway, probably to reinforce that there are some solutions. You can buy clip-on ferrites that you can clip on. You'll notice that most equipment, here we go. There is a ferrite on the end of each of these cables, and usually on your power supply, etc. That is to assist the electromagnetic capability of that device in an RF field, because the RF field gets absorbed by the ferrite, not introduced into the device. So that's one of the ways that particular works. They're all available from Jaycar. The RF is absorbed by the ferrite and filtered out. Now, RF earth, the concept of there being an RF earth in your shack. So you'll notice you've got your power supply and you've got a main safety earth, which is the earth that is on your main socket. But this is introducing the concept of there being an RF earth. So a separate earth where any RF, stray RF signals and currents can disappear into the RF earth, and you can see all of those devices are all bonded together at the same RF earth. So this can be an earth stake, it can be a water pipe, it can be whatever, but not your mains safety earth. Because if you connect your RF earth to your main safety earth, you're probably introducing a whole lot of pain, because the interference signals that you're trying to get rid of with your RF earth will all be introduced via your main safety earth. So yeah. Okay, some questions. EMC problems are dependent on 4 factors: transmitted power, frequency, type of emission, and distance. Move it further away. I like this one. Objectionable, not harmful, objectionable interference from your amateur station to a domestic television reception can vary with, I think it's A.
Technically all of these, but D, presumably.
Mode of operation. That's one of the 4. That's the only one of the 4 that's in that list.
Tell me the zodiac cycle's not
Oh,
But zodiac
I like
cycle
that.
would be based on seasons, which would then
Yeah.
correlate with weather.
Yeah, well,
It's not
okay.
as silly as-
Interference to domestic equipment may be reduced by.
Changing the transmission modes while reducing the gain control.
A is the only one of the 4.
I guess if you were using a transceiver and you reduce the RF gain.
But it's a receiver. It's not a transmitter.
Okay.
So yeah. Now you'll notice that there are a lot of questions for interference and safety. So your amateur station is causing harmful interference to radio services. You must.
Stop transmitting.
Well and truly. I wish you luck with C. One-way interference can be fed into nearby electronic equipment.
Via the mains.
Yes. And one of the hardest to track down, but one of the easiest to test whether it is that or not, use your equipment on batteries. So take the mains out of the equation. Interference resulting from EMC problems can be minimised by
Chaos exception locating your antennas.
distance. Again. You can see that they focus on interference and safety. Interference resulting in EMC problems can be minimised by
Reducing current, increasing distance, which is transmitting
read it very carefully because B and D are there to trick you. You don't want to reduce the distance, you want to increase the distance. So it's reduce power and increase the distance.